Hello everyone, good morning. This is Mr. DHAKSHUNHAAMOORTHY, Assistant Professor, Artificial Intelligence and Machine Learning Department. I am handling subject 21 CS 003 Mobile Application Development, Unit 1 Wireless Communication in Cellular Networks. Topic is Overview of Cellular Network. In the overview of cellular network, there are different components like user equipment and then base station, trans receiver, and then mobile telecommunication switching office and public telecommunication switching network, which is connecting to the public network. If suppose one of the user equipment wants to communicate to some other user who is traveling in the car, then the UE is communicating directly to the base station receiver, trans receiver, and then that signal is directed to mobile telecommunication switching office. This telecommunication switching office is directing that signal to the passenger who is traveling in the car. In this slide, wireless communication definition, in which the first component which we have discussed is base station, a fixed station in a mobile radio system used for radio communication with mobile stations. The base stations are located at the center or on the edges of the coverage region and consist of radio channels and transmitter and receiver antennas mounted on a tower. Next, very important part is mobile switching center. Switching center which coordinates the routing of calls in a large service area in a cellular radio system. MSC, that means mobile switching center, connects the cellular base station and mobiles to PSTN. Here the field called page, which consists brief messages, which is the broadcast over entire service area. The trans receivers, a device capable of simultaneously transmitting and receiving radio signals. In this slide, uplink, downlink and a control channel part we are discussing. Forward channel, that means the radio channel used for transmission of information from base station to the mobile. Then this one is downlink. A reverse channel or uplink, here the radio channel used for transmission of information from mobile to base station. Next, control channel, the radio channel used for transmission of call setup, call request, call initiation and other beacon or control purpose. Cellular concept. Cellular concept is a system level idea which calls for replacing single high power transmitter with many low power transmitters. It offers very high capacity in a limited spectrum allocation. Each base station is allocated the portion of total number of channels available to the entire system. The neighboring base stations are assigned different groups of channels so that the interference between the base station is minimized. What is cell? Each cellular base station is allocated a group of radio channels to be used within small geographic area is called a cell. Cell shape, circles, equilateral triangles, squares, hexagons. Here the geometric shapes which cover an entire region without overlap and with equal area. In the cellular geometrics, when we are using a square pattern, in such cases, the center to that means we are taking the distance between each cell's center to the mid cell center. Here the diagonal length is 1.414 d, that means root 2 times of d, and in the vertical and horizontal distance is only d. So here distance varies in the diagonal portion. That is why we are going into the hexagonal pattern. For the center cells origin or center that the base station to adjacent cells base station is equal distance, and also that base station to edges also equal radius. That is why we are suggesting hexagonal pattern of the clusters is the best way of cellular cluster formation. The frequency reuse, by limiting the coverage area to within the boundaries of cell, the same group of channels may be used to cover different cells that are separated from one another by distances large enough to keep the interference levels within the tolerable limits. The design process of selecting and allocating channel frequencies for all cellular base stations within a system is known as frequency reuse or frequency planning. Frequency reuse, in this slide we can able to see the reuse distance d. Here each cluster is having different band of frequency f1 to f7. Here the same f1 frequency band we are using in the different clusters, then we are reusing the particular frequency band in the different clusters, and the reuse distance also we are measuring between one cluster frequency band with the similar kind of another cluster frequency band. Here fx, that means set of frequency. Here 7 cell reuse cluster. Here f1 to f7 in each cluster. This one is 7 cell reuse cluster. Reuse distance we are measuring with the formula. For hexagonal cells, the reuse distance is given by d is equal to root 3n into r, where r is the cell radius and n is the reuse pattern we are using. Reuse factor equal to reuse distance divided by the radius r. Then we are getting root 3 of root of 3n. Reuse distance, here in this slide we can able to get the number of cells per cluster, that value from the various arrangement of the cluster formation. Here n is equal to I square plus ij plus j square, where I is the radius from the center cell area to the adjacent cell areas base station, and the j is the distance between